Cool. Good morning, everyone. As expected, after a big party, not a full room, but that's okay. It's going to be cozy. We're here to talk about how we migrated, we started migrating, we haven't finished yet, our code base to Kotlin. It's been an ongoing process. We've started 3 months ago, so the results are still not finalized, but hopefully we'll get a discussion going. Mandatory who I am slide. My name is Savvas Dalkitsis. I'm the principal software engineer for apps at ASOS. I used to lead one of the two Android teams that we had though during that transition. So a little bit about who is ASOS. You might not know the company. It's basically a fashion company. We sell clothes online. That's sort of the mission statement. To become the world's #1 online shopping destination for fashion-loving 20-somethings. It's not limited to only 20-somethings, so even if you're above that, you can still buy our clothes. They're quite nice. We don't have any brick-and-mortar stores, so it's just online. And recently we made a really big investment in mobile, because it used to be mostly the website. So our main traffic used to come from the website. Big overview of the team structure that we have. It's a bit complicated, don't worry about the details. The idea is that we have the iOS and Android team together. Each of these teams have about 2 or 3 teams each. They're basically functional, agile teams. We still all work together. We have a director of technology above us, and then some platform leads and BAs and stuff. Now, the reason I'm showing you this is to basically tell you that this is a mature project. This is not a small side project that the company has. This is sort of like the main client now that the company is investing in. The Android client has had almost 20,000 commits. I think actually, as of yesterday, we have actually overcome the 20,000 barrier. The first commit was done in 2014, so it's like 3.5 years old now. So there's a lot of code there, and about 20,000 files. And like I said before, mobile is really important to ASOS. 75+% of the traffic now comes through mobile. That includes mobile web, of course, and the native apps. And 60+ of the revenue comes from mobile. So that's basically where the company is headed. And the native apps specifically are where we have our most dedicated users. So basically the website is mostly to attract new users into the website, and once they start using us, they will then go to the native apps. So taking any decision like changing a language is not something that we would take lightly. But we still did it anyway because we think the benefits really outweigh the risks. We're not afraid to use new technologies or anything like that just because we have a really big project there's a lot of stake. We use all the standard stuff like Butterknife, RX, OKHTTP, Retrofit, and Espresso. But what about Kotlin? We all loved Kotlin. Like all the developers were really excited about Kotlin, but of course, you can't really go to your boss and tell them, I want to use this new experimental language that is not officially supported by Google. There's not a lot of investment there. There's no guarantee that in the future you'll be able to hire developers that know the language. So it's a bit investment. So on May 17th, when Google announced that Kotlin became one of the official languages supported, I was very excited, as you might imagine. I was actually at Google's offices in London watching the I/O through the Google I/O extended program. And immediately when they announced it, I sent this message to my director. This is the actual thing. I went back to Slack and found this. So immediately I told him we're moving to Kotlin, which of course didn't happen right away, but basically the push was there. Everyone on our team was really on board to try to do this change. So why do we love Kotlin? Well, many of you may already know all the basic things about why Kotlin is amazing, but I'm going to go through a really quick example. I think the easiest thing to hook people into Kotlin is to talk about data classes. Do people here know what data classes are? Raise of hands if you know what data classes. Okay, maybe half and half. Okay, so it's not going to be completely wasted on you. So basically, that's I think the easiest thing to show people, and it also has the most gain for the least amount of effort that you can do. So we're going to show a little bit more, a few more goodies later on. But let's talk about data classes. So let's say you have a model. Details not important. It has some name, surname, age, height, address, country. Doesn't matter. Now, you have your getters, of course, below that. And your setters, and your hash code, and your equals, and your toString. And it's ugly, error prone, because when you add new fields, you might forget to include them in your equals, or your hash code, or your toString. And it's just big, and it's not nice. We don't like this. The equivalent exact equivalent of this in Kotlin would be this. Literally just what? 1, 2, 3, 4, 5, 6, 7, 8 lines long. Or you can condense the whole thing in 1 line. This is exactly the same piece of code. It generates the same bytecode more or less. You have access to the getters, the setters, everything. Now, of course, I hope most of you would immediately go, but I don't want to have my beans be mutable. It's a bad practice. So let's look at the previous example again by making it immutable. So this is what we had, really big class. Let's remove the setters. It's not as bad now, it's slightly smaller. But first you have to have a way to create these objects. If they're immutable, you can't set the fields. So you either have to have a constructor that takes all the parameters here in, or you have a builder. So if you add the builder as well, you get this monstrosity, just for like 4, 5 fields, which is ridiculous. You don't want that. So let's go back to the data class. Let's see how we can make this class do almost exactly the same thing as the previous one with immutability and a builder. Now, blinking, you'll miss it, so everyone pay attention to the screen. Right? 3, 2, 1. Right? That was it. We made it immutable by making sure that the fields, the properties are values now, they're not variables, so you can't change them. And the way you construct the object, I'll show you later on, is that you use name constructors and copy constructors. We'll talk about them in a bit. All right, so I convinced you. How do you convince your manager, though? Because, you know, it's still an investment. Well, since it's now official, you can basically tell them it's supported. There's not going to be any risk of potentially investing in a language that will not be given the appropriate support from Google. And actually, they're committed to it in the long term. And if you need to convincing, or your team needs convincing, Google has now started and officially basically said that the platform itself will have lots of components written in Kotlin. They actually hired Jake Wharton, I think, like 2 months ago, to work on Kotlin in Android. So this is happening. I predict in like 3 or 4 years, no one will be writing Java anymore for Android. Everyone will be using Kotlin. So you need to get on that early so you can actually, you know, learn the language. And it will also help you with recruitment because it is a thing that most developers really want to play around with. So if you can advertise that your company is at least partially working with Kotlin, it's an incentive for people to come and join you. So, right, they're convinced. They might need a little bit more. So what we did, basically told them, I went to my manager and told him, listen, we want to do Kotlin, everyone wants to do them, all these reasons that I explained, but let's minimize risk. Because, you know, they're a business, they have to minimize risk. So we decided to work on a feature. This is our social connect screen in the new My Account page that we created recently for the app. But it's a small feature. And it's a small isolated feature. So the idea here is that even if things don't work out, who cares, right? Okay, we invested maybe 1 sprint, a couple of weeks, it didn't work out, oh well, you know, we learned, let's continue. Of course, thankfully, that's not what actually happened. We all loved it, and the transition was mostly, it was very smooth, let's just say. All right, so where do you begin? Well, it depends really on your team's level, not just in like skill generally, but also have you ever heard of Kotlin before? Have you played around it on your own time? Complete beginners should definitely do the colons first. So there's the link there. I will share the slides afterwards. This is basically just an online tool. You can also get a plugin for Android Studio. It's literally just a series of tasks that you do to learn the language. It teaches you all the basic constructs and a few of the cool tricks that Kotlin has. I definitely recommend this. Even if you know Kotlin but you haven't done the colons, I would definitely recommend you try them out because they're really fun. Intermediate and you know, well-rounded developers should, you can just dive in because the interoperability is amazing. It has a few kinks here and there, but generally there's not a lot of problems that you will encounter. You can literally just start writing Kotlin today. Okay, but where do you begin? Like in your project, literally, where do you start? Well, you need to put Kotlin into your project first of all, obviously. So, you know, you put this in Gradle, very simple. You just basically apply the dependency, and then you put the plugin in, that's it. Also, if you're using any annotation processing libraries, you may need to convert all your APT declarations to KAPT, like butter knife and things like that. But for the most part, it's literally just adding the new plugin and just replacing all the words APT with KAPT. It's very simple. All right, then what? Then what do you do? Well, We found that most gains are exactly like we discussed with the data classes. Most gains are to be had at that layer. And of course, the classes that construct them and use them. So we decided to begin there. We would basically start with our model for this new screen, and for the classes that use them, like our mappers, our interactors, whatever you basically use cases, whatever you call them, the things that transform basically data from one format to the other. And if you're not comfortable, convert to Kotlin is your friend. Basically, the idea is that you can have a Java class converting to Kotlin for you. Most of the time it works, but sometimes you have to tweak a little bit to get it working. So let's look at an example of that. Let's say you have a directory repository. This gives you a directory of people. Very simple interface. The directory, which is a list of persons. So you have people, basically. Note that this list is potentially nullable, so this will become important in a bit. And person, just a simple data class with like name, age, email, address, country. All of these really big classes like we showed before. We had to string, hash codes, equals, all that jazz. Right, and then you have a user model, which is the kind of thing that you want to display on the screen. Just name and email, very just basic stuff. And then you have your actual use case, which is the thing that, in this case, I just created a very basic one, which is basically the converting the people in the directory to the eligible users. So eligible in this case is people that are above 18. So look at the code a bit. Very simple. You use the directory. There you go. You use the directory repository to get the directory. You get the people out of the directory. If the people are null, you return an empty list for the user models. Otherwise, you create a new list of eligible users. You iterate through the people. You get their country. If the country is not null and the country code is not null and the country code is the same as the country that you asked for, you want to get eligible users in a specific country, and the person's age is more than the legal purchase age, which is 18, then you add a new user model using the builder there with email and name into this list, and then you return the list. Very simple thing. Not really doing anything clever there. Now, let's convert all these classes automatically to Kotlin. You do this by just right-clicking anywhere in the class. Actually, no, it's not a right-click. I think it's there's no shortcut for this, but you have to use Command Shift and A. Like I said, there, he's your friend. This is a very useful shortcut for Android Studio. Even if you don't know this now, this will help you do like anything you want in Android Studio. You press Command Shift A or Control Shift A in the Windows system, and if you just start typing something, you will find the action to do it. So if you just type convert to Java to Kotlin, you'll get that option. You can also paste Java code if you have it in your clipboard and you create a new .kt file, like a Kotlin file, and you try to paste it. It will ask you to convert it automatically for you. So it will do exactly the same thing. So let's look how all of these files get automatically converted. This is without me doing anything. This is just right-clicking or doing the Command Shift A thing and converting it. So the interface is more or less the same. Like I didn't really need to convert that, but since we're converting this to Kotlin, why not? The directory is slightly shorter now. The builder is now in the same line. The constructor basically for Kotlin classes gets in line in the same line as the declaration of the class. That's the main constructor. You have the list of people. Your init block gets executed after the constructors. You read them from the builder. You might notice that the people here is red. That's because that's one of those things that I told you doesn't always work on 100%. It basically converted the fields in the builder as private variables, so they're not visible to the encompassing class. But you can fix this by just removing the word private here, so it will compile. Same thing for the person, exactly the same class, basically like the structure, like the directory, list of things, initialize them, they're red, but you can fix them by removing those private declarations there. User model, exactly the same thing, it's a bean, same problem with the private thing. Now, what about the use case? Now, this already looks kind of smaller because of the whole, injecting the directory repository in the constructor, all that goes away. And, it's slightly different. You say for people, for person in people, a little bit of that, but it's basically the same class. There's nothing fancy there. You might notice this doesn't compile. That's, again, because the builder was private, but you can, again, fix that. So even without doing anything, just removing a few private keywords, you converted something to Kotlin, and you now have Kotlin in your code. But of course, that's not idiomatic Kotlin. You want to fix this. And this is where that was one of my favorite things to do in Kotlin. Not anymore, because now I start to write code in sort of the Kotlin way. But initially, when I was first learning things, I would write them in a sort of Java way, like more, let's say this is very non-Kotlin. You're doing iterations over things. You're getting values out of things, and then you're checking against them. We'll show you how to make this much better now. So one of my favorite things is to go from the deepest level in like a method and work my way out and see what I can improve. And most of this stuff you get automatically by the IDE. So let's start with that. Actually, before we go into this class, let's talk about the data classes. All these other fields that we talked about, the user model, the person, they were basically data classes. They were classes that contained a list of fields that you wanted to read as immutable values. So the same classes that like we saw before can now fit in one screen altogether. Again, data classes are amazing. This is exactly the same thing. We've talked about this already. So let's go back to the use case. All right, we're going to remove the builder first. Like I said, we're going to work our way from the innermost branch outwards. So we'll replace this bit here. So instead of using this builder, which we don't have anymore, we converted the class into a data class, we're going to use the name parameters. So you do this by literally constructing an object. This is the constructor call. You don't have to use the keyword new in Kotlin. And you basically say the email is that, the name is that. You can skip this, like the actual email equals and name equals, but they're nice to have because they make constructors in Kotlin look like builders. And this is what I meant before, that you can get rid of builders and get something that is very close to it. It's not exactly the same because you can't actually hold on to a builder and mutate it as you go along. It has to be all done in one declaration. But I'll show you in a bit how you can get around that. Right, next we're going to remove those null things. I don't know if you've probably heard Kotlin is amazing when it comes to null reference handling. So, okay, let's get rid of this line then. We don't want to check if the country is null. We'll just remove it. Gone. But now you'll see, of course, there's a compilation error. There's a little red line there. I don't know if it's visible, but the idea is that you can't just dereference country. It might be null. You're going to get a null pointer exception. And Kotlin helps you there. You can also do an alt-enter tip to help you to get some hints as to what you can do. But the easiest thing is to just basically put a question mark there. So this is where Java would fail. If you remove this line in Java, everything would continue. You might get an ID warning because you have the nullable annotation on the field, but you don't always remember to put this annotation in all the fields, so sometimes you forget, and you get null pointers. And even if you do have the annotation there, sometimes just people ignore it, which they shouldn't, but sometimes they do. So how do we fix this? We put question marks before the dereferencer. Country question mark dot code is not null, and country question mark dot code is country code. Now, we can do the same thing here, like we did before. We don't have to check for null, but you might notice that the ID already is complaining. It's giving you a hint there that you've already checked that country is not null. You don't have to do this anymore. So I could, on the second declaration, remove the question mark. So Kotlin is smart enough to know that, okay, we've now guaranteed that this is null safe. You can just use it as a proper type. But we're just going to remove the whole thing. This whole if block basically can become very simple. You just do country question mark dot code equals country code. Now this will work even if code is null, because you no longer have to do a dot equals call on the code to check it. You use the equals operator. In Kotlin, two equal signs are not the same as they are in Java. In Java, this operator would check for reference quality. It would basically go, are you the same object? Not do you have the same values? If you wanted to do that in Java, you would have to do dot equals. Here, this is the equivalent of dot equals. If you want to do identity checks, you put 3 equal signs. So that's already better. What else can we remove? Well, another idiomatic Kotlin thing is that anything that has methods that are the standard sort of operation methods, like adding, removing, that sort of thing, because you can have operation functions, you don't need to type the word .add for the user model. You can literally just do this. You say plus equals. So you're adding things into the eligible users. That's already nicer. Let's also inline the country. Like the fact that I have this as a value, a bit pointless. I mean, I'm only using it in one place. Let's just remove that, right? That becomes 1. But now you notice the ID is highlighting the 4. That's interesting. So what does that do? If you do the alt-enter or just right-click and get the hint, it tells you that you can replace this with a filter and a for each. Because if you think about it, what are we doing? We're iterating one collection, we're getting rid of some things, and we're adding all the other things in another collection. So this is effectively a filter. So let's do that. This was automatic. We didn't type anything. This was done for you. So now from the people, you filter the ones that their country code is the same as the country code and their age is less than whatever. And then for each of them, you add them into the eligible users. Now another thing that you should really know about Kotlin is you very rarely have to collect things into other things and then use that other thing. You basically have, well, you can do this obviously, this works and compiles, but the idiomatic way is to do operations on collections. So in this case, what are we doing? We're creating an empty array list and then iterating another list, and then for each item, we're moving this item into that other list. You don't need that. You can literally just convert each of these items that are emitted by this filter method into this new thing that you need, and that's your collection. So you do that by mapping. That's it. That's already much nicer. We got rid of that declaration of the array that we didn't need. And this is much cleaner to read, in my opinion. You're basically saying, okay, from the people, I filter the ones whose country code is the same as the country code and whose age is more than the legal age, and I map them to this user model. And that's the same thing. This, really quick note here, this might, I think in this case it might not, because I think the Kotlin compiler is clever enough, but doing this type of, converting your code from collecting things to just mapping and flat mapping them, might do multiple passes over your collection. So if you had 10,000 people in your directory, you're now basically filtering all of them, so you're iterating through all of them to filter other ones you don't need, and then you're also mapping them, so you're traversing them again. So this might not always be the best solution for you. I don't know if actually Kotlin does that. I know that like the Java 8 equivalent methods of this, that the stream methods, you have filters and maps and everything, they've made sure that very small compositions like this only do one pass. So they know that, oh, you want to filter and map, so they do the two steps in one go. I'm not sure if Kotlin does that. We'll have to talk to a Kotlin expert and ask them. Right, so let's also inline people. Like we did before, people is only used in one reference. There's no need for me to have a value. So we're just going to take this whole thing and put this here. But of course, I can't put the return. Anyway, let's just put this in and see what happens. So you put that there, and you might notice there's another red thing here, because people might be null. Another point where Java would fail you. This would throw a null pointer exception in Java, or you would get a warning in the IDE. Right, so how can we fix this? Okay, I can do the whole, I can revert it back to how it was and check for the null. Or I can do a let. I will tell you in a bit how lets work. Or we can do this crazy thing. Or empty. Now, this might seem natural. Okay, we get the people, or empty if, I don't have people. But notice what happened here. I called the method on a null object. So Kotlin allows you to do that. Well, you're not actually calling a method on a null object. You're calling a method on an optional type. But if people is null, you're basically calling a method on it. So you're effectively saying, if people doesn't exist, give me an empty list. There's a lot of these that are built in with Kotlin, and you can define your own. It's a very powerful tool. Right. Might as well inline the directory then, because again, it's only used in one place, so why not? Let's do that. That didn't need any compilation errors. It was, it was okay. Directory was never null. So good. That already looks amazing. But another thing we can do is that everything in Kotlin, almost everything, for the purposes of this talk, everything in Kotlin has a return type. A method that has no return type actually has a return type. It's a unit. If statements have a return type. Return statements are effectively the type that they're returning. So what you can do here is, instead of giving a body, creating a method that has this body that returns a value, you can assign to this method the value of this. So you can do that by doing that. You will go to the word return, you alt-enter to get the hint, convert to expression body. What this does is literally just gets rid of the body, the expression, the curly brackets. It just says this method is equal to this thing. This is the same equivalent code. At the same time, you can go even crazier and use Kotlin's type inference. So if I didn't give you the declaration of the body, and you went to this map thing and did Control-J, which gives you the information about the method you're calling, basically, the type and the parameters that it gets, you'll see that the return type of this map specific is a list of user models. So Kotlin knows that this whole expression here its type is list of user model. And we've already defined it here. You don't need that. You can just get rid of this. And it works. So this is exactly the same piece of code. Now, you may have noticed the companion object that we've had there for some time. Now, Kotlin doesn't have static. The notion of a static thing doesn't exist in Kotlin. But you have the notion of basically singleton classes. They're not really singletons, but the idea is that, yes, they are a single instance of an object. So instead of saying class something, you can just say object something, and you can only have one instance of that specific type. But classes can have companion objects. So if I create 3 of these use cases, they will all share the same companion object internally. So this is how you can define static context for classes. But for this case, we only need this to define a constant. So you don't need this companion object. This is just dead weight. Now, Kotlin, of course, in a Kotlin file, you don't only have to put one class. You don't only have to put a class. You can put anything you want. You can just put random functions that exist at the top level of the class. You can also put declarations of fields and constants. So we'll take this whole line and move it out of the class. And it will look like that. This is still valid. And you'll notice we'll get a little yellow line there. That basically warns you that you can make this a const. So in Kotlin, the word val is very often misinterpreted to mean immutable. That's not the case. The fact that you have a value of something does not mean that the value is always the same. It means you can't change it from the outside, but internally, it can vary over time. You can have a value exposed that gives you the directory of people. Actually, this whole .people method the .directory method that I added on the repository could have been a value. And the directory might not always be the same. The people method could be a value, that you get different people every time. The idea is that you can't set values to them. But a const effectively tells you this value will never change. So for values, you can actually put this in. Now, this doesn't work for any type. It works for some of the primitive types that Kotlin supports, string, all the number types. Over time, hopefully, there will be some more support for your own custom type, so you can create const values of your custom classes. Anyway, this is effectively the same code as the one we had before. It's really small, as you can see. It's effectively 3 lines. Like all the other stuff, you can just ignore. And it's good. We like it. This does exactly the same thing as the previous class, and it's much more readable. Just to compare, let's go back to how I compare these 3 lines to this. They do exactly the same thing. This is not nice. We don't like this anymore. I can't write code like this anymore. It gets on my nerves when I go back to an older class that is too long for me to completely rewrite in Kotlin, and I have to add code that looks like that. I don't like it. So I always create really, really long PRs, and my coworkers hate me because I tend to convert everything to Kotlin when I touch it. Right. We'll just give you a quick example of how some of these classes look in our code. So an activity, tiny. We of course have a base activity here that basically creates a toolbar. But, you want a fragment. This is an overridden method, as you can see by the keyword override here. I don't need to have a body. We can literally go get fragment equals this. I created a new fragment. Toolbar title is literally equals to that. So you can have a lot of declarative style programming with Kotlin. It doesn't always work like that, but this is another example where we use the companion object. In this case, we still called this from Java. So we needed a static method to access to create new intents for us. This is a pattern that we use in our team. Whenever you need to launch an activity, you have a static method on that activity called new intent with any parameters that you might need. In this case, nothing. But if this took, let's say, I don't know, a URL as a parameter, there would be a string here, and you would just put it in the intent. Let's look at how a presenter looks in Kotlin. Very small. Don't worry about the details. The idea is that for very quick classes, you have this very, very condensed code. It's very easy to digest. You can read it really easily, and it just looks much nicer, I think. Now, do we get everything right? God, no, we really don't. Sometimes we just get really excited and just stop writing Kotlin and writing and writing and writing, and we end up with classes that look like that. This is Kotlin. Don't worry about it. It's huge. We need to break it down. But yeah, you can still, Kotlin will not make your code be amazing by default. You still have to work on it, basically, is the takeaway. This would be even bigger if it was Java, though. That's the point. Probably 2 times longer. All right. So how are we doing? This is kind of the thing that we started with. But I think everyone got infected with Kotlin, so everyone is now, every new class that we write, maybe 95% of the new stuff that we write is written in Kotlin. And many times you see some PRs that literally say, this is good, maybe make it Kotlin. So we started converting existing classes as well. It's not just for new stuff. So, how are we doing? This was taken yesterday. We now are at 5.1% of our code base is written in Kotlin, basically. It's actually more than that because a lot of the Java stuff, is basically test code that is legacy. Most of the new production code that is written is purely Kotlin. So the number would probably be a bit higher if I only limited this to the production code. We only, like I said, we started 3 months. That was the first commit that was in Kotlin in our code base, and it was basically in June 28th. So in 3 months, we've gone to 5.1%. Now at this rate, it would take us about 2.5 years to go to 50%, which doesn't sound very exciting, but it's actually accelerating. So, in the first 3 months, we were, we weren't doing everything in Kotlin, and especially in the first couple of months. Now, lately, we've started doing this. So I predict it's going to be, we're probably going to reach 50% by next year, especially if we start converting more of our legacy code, which I really would like us to do. All right, so is it all fluffy clouds and bunnies? It really isn't. There's a lot of stuff to love about Kotlin. There's a few things, though, that are a bit annoying. Not really problematic, not enough to cause us not to use it, of course. So, parceling. That's one of the big pain points in Java. You have to not only have a toString and an equals and a hash code and whatever, you also, when you have view models and you want to save them in your activity or whatever, you have to also make them parcelable. Now, there are plugins that do this for you in Java. I think there are some in Kotlin as well. But you use things like paper parcel. This is what we use. You just end up with this annoying thing that this class doesn't exist. You have to rebuild your whole project for the annotation processor to kick in and create a new class for you so you can use it. Very small thing. We don't always do this anyway, so it doesn't really cause us many problems. Plus, Kotlin now introduced an alpha version of their parcelize annotation, which is basically their automatic way of creating parcels for you. It doesn't work very well, especially with like really deeply nested data classes. It gets confused sometimes with creating the proper parcel code. Have a look at it. But eventually it's going to go out of, I think it's in beta actually now, so it's going to go out of beta soon. Small things like, you're in an instrumentation test and you want to run it, and you get this annoying pop-up that you used to get in the early days of the instrumentation test runner anyway. I remember the days when they first introduced the JUnit for Android. You would run a test and it would ask you, do you want to run it as an Android test or as a unit test? And you're like, I'm in the instrumentation folder. Of course I want to run it as an instrumentation test. With Kotlin, you still get this. This will probably be fixed though. Refactoring is another thing. For people like me that love refactoring, like I basically type less than half of the code that I write, I actually manually type. Most of it is refactored out for me. I'm a big fan of refactoring, and the refactoring support with Kotlin is not great. An example, let's imagine this very small structure. You have a module class that just creates some classes for you, a Kotlin module class equivalent, some class, some dependency, and some Kotlin class. Right, so in the module, if you have some class, and you want to add a dependency on it. Like the way I would probably do something like that is this. I would go into the class. I would create a constructor with refactoring. I would go in, create the new dependency that I needed, then extract it as a field, and then extract this as a parameter. All these with shortcuts. And now if you go back to the module, you see that basically Android Studio put the dependency back there. Now let's do the same in Kotlin. Again, there's the primary constructor. I can't really put stuff in there. So okay, guess I'll create a secondary constructor. Go there, put the same thing, create a dependency, try to extract a field, and it doesn't work. Okay, let's make it a parameter then. Cool, we made it a parameter, and it works. It does move it up, but now it's not a value. It's not a field that I can access in this class. All right, I'll just go and type the word val, I guess. And it doesn't like it because secondary constructors don't have parameters. So Alt-Enter, convert to primary, now it works. So you can get there, but it's just really annoying. The whole point of the refactorings was that it's automatic. Even worse, if you try to do the same thing, but you call this constructor from Java, so you call a Kotlin constructor from Java, like we do here. Let's create the the call, right? So now in Kotlin, if you try to do extract as a parameter, it does it, but then if you go to Java, you see that it just doesn't work. It doesn't recognize that it's Java. It's small, you can just type the word new. These are really small annoyances. Like I said, not important enough for you to say, no, I'm not going to use this. Right, so inlining. Inlining is another big refactoring that I like to use. This example that I have here is very contrived. You would never do this, but inlining Kotlin to Java doesn't work that well. So let's say you have this method, do something on the class, and the same method in the Kotlin class. They both do something. Now, from Java, if you try to inline the Kotlin class, it doesn't work. It tells you that the refactoring is not available. If you're in Kotlin, you try to inline the Java class, still same thing. So, you know, again, if you're in Java and you try to inline the Java one, it works like this. You can basically say, I'm going to keep the method, and it just brings it in. Again, this specific example you would probably never do, but inlining in general is a bit iffy. I haven't shown this yet, but another cool thing that you can do with Kotlin is that you can use spaces in names of methods by backticking them. So there's this little backtick before and after. This is amazing for reporting. When you get your unit test, you have to use either camel case or underscore case, snake case I think it's called. It's very annoying. This you can just write full sentences that are very descriptive. The problem is they don't run on the Android runtime. So you can't have them in instrumentation tests. By default, you get this warning every time you try to use this method, you will get this basically. It will tell you the identifier is not allowed in Android projects. You can use this in unit tests that you run on the JVM, on your laptop or your CI. So we use them for unit tests occasionally. I'm a big fan of them. Not everyone in my team is, but you know. So the way to fix this is to go to the preferences of Android Studio, inspections, and there's going to be a section called Kotlin Android and a legal Android identifier. You can actually go into that one and then add a new scope and say, in the instrumentation test, give me an error, because it won't work if you try it, but everyone else allow it. So this will just work. There's a few smaller things as well. Build times are technically longer with Kotlin because depending especially on how much interoperability you do, Kotlin may have to compile, do cross-compile. So you're compiling your Java class, okay, cool. And if from Java you're calling a Kotlin class, you have to compile the Kotlin project. And then if in your Kotlin project you're still referring to the Java class, you have to go back and compile that one. So technically it can be longer. These things can be fixed though with new releases. So hopefully in the near future this won't be an issue. And we haven't really noticed a drastic increase in our build time anyway, so we just basically accepted it. Also, switching branches can be really annoying sometimes. Like if you've built your project, it's compiled all your classes, everything is good, and then you switch to another branch. The Android Studio plugin doesn't clear the workspace off of the classes that are no longer present in this new branch. So you end up with things like, oh, this thing, I don't know what it is, and you have to clean the whole project, which can take some time. So yeah, again, these things are going to be fixed with the Gradle plugin and the Android Studio plugin over time, hopefully. So again, not a big deal for us, so we just basically said we're going to use it. All right, I don't want to end in a bad note, so I'm going to show you some more bunnies, some of the good things that Kotlin has that we love. First thing we love is Elvis. Elvis operator is amazing. You can basically say, let's say if you have a method called retrieve person age that gives you an int question mark, so it's an optional age. You might get null. I know this will probably never happen because there's no way to have someone in your model without an age, but let's say that you can. Now, you can do this in somewhere else in your code. You can just say, okay, retrieve the person age or else 0. So you don't have to say, okay, get me the age. If the age is null, use the default value or else, just the Elvis. And for those of you who don't know, you probably all do, but this is called the Elvis operator because if you look at it on the side, it looks like Elvis Presley with a little hair. You can also do things like that. You can say retrieve the person age or else just throw an exception. I want some age. I don't have some age. Give me some age. Now, you can also return from here. You can literally say in your method, okay, I need to retrieve the age of this person and then do some stuff on it. But if the age of the person is not there, I need to return a default value of my whole method. you can say return person age or else return something. And this will basically return whatever you give it in the context of this method call, which is really cool. So no if statements anywhere. One of my most favorite things is named parameters. Named parameters are amazing because they give you a builder-like syntax for Kotlin. So like we said before, we have the person data class that has like, name, age, address, email. You can call these like that. This already looks like the builder that you have in Java if you have builders, where you say, person builder dot with name that, with age that. This is cool. Now, you can do nested things, of course. So let's say if the address was another data class, I would say address equals address, and then have another block here with, line 1 equals that. So you have a nice, basically structured hierarchy of your beans. You can leave them out. You don't have to put them. You don't have to say name equals age equals, like I said. But if you do that, you have to maintain the order. So you have to call these parameters in the order that you define them in the person. If you have these, the order doesn't matter. You can call them in any order you want. Kotlin will not complain. So yeah, it's an all or nothing. Now, another cool thing with data classes is that you have default values. So, going back to this, let's say we want to make the email address optional, which it already is, but I still have to define it. If I don't put the words email equals something, null, it will say, I don't know what this is, you have to give me a value. But you can go and define the default value here in the declaration of the data class. So now going back to the previous example, I can just skip the whole email thing completely. I don't need to define it, because by default it's null or whatever it makes sense in your model. Another cool thing with this, and this is where you get a little bit more of what the builder gives you, because the builder, gives you a nice way to construct an object with like names and everything, but it also allows you to hold on to a builder and conditionally add things to it, which you can't really do in Kotlin because this is just the final object. You can't just modify that. But you can create another object that looks exactly like that with a small change using the copy constructor. You basically say object.copy, and here you have access to all the constructor parameters like before, like you're constructing a new object. But you can only specify like some of them. So basically I'm saying, I'm going to copy me, and I'm going to give me age of 50. So now I have a new object, immutable again, that has all the same parameters as the first one, but with the age overridden. This is a little bit expensive, especially if you have like a really deeply nested tree. Every time you copy, you're basically copying all the values across. So, it's not exactly like a builder, but it's close enough. It works for us. So another cool thing is long nullable chains. Like we showed before, you can just basically have a null safety referencing method. You can just say !dot, and you can just keep at it. You can say, checkout dot backstock reservation, !dot, we don't know, we might not have a reservation, out of stock items, or empty. Again, this might be null, so we're calling a method on that. Filter that with where the price, which might not exist, discount, which might not exist, value, or else 0. Because again, this might be null, where this whole thing is greater than 10. This whole thing will give you a list of items or null. Because we have this whole, if any of these things fail, well, actually this whole thing will not be executed. So you're just going to get a null object back. And again, like I mentioned before, you can actually call methods on the null object, which is crazy. Right, filter, map, reduce. Basic, functional constructs. Every language that has some functional capabilities has these 3 basic methods. So it's very simple. You're getting the people, and we filter out the ones that are above 18, like we said before. So you're just going to get a list of people that are above 18. Now, you can map people. So we're saying, print me the people, map their age, filter the ones that are above 18, and then do average. This will immediately get a list of integers that are above 18 and average them out. You don't have to do this by yourself. Filter, same thing, filter everyone above 18, and sum them by their age. Now, sum by is sort of a helper method. It's effectively a reduce. A reduce, for those of you who don't know, you have a collection of things or a stream of values, and you reduce them all into one thing by an operation that is applied on each individual item. So it's like a fold. A fold is also a functional construct. It's effectively the same thing, but a fold starts with an initial value that you specify, whereas a reduce starts with the first item, does the thing you gave it, and just keeps going. So in this case, we're basically saying these last 2 things are the same. You're basically filtering the age, and then you're reducing all the items into their their addition. So you basically have the total and the current value, and you're saying total plus current. So these two things are equivalent. And of course, this prints 20, 40, and 40, if your list of people is, this. Another very, very cool thing is extension methods. You can add methods to types you don't own, which is incredible in Android because our methods are tricky. We're running out. Very quickly, you can add methods to an intent like this. Let's say you add a method called navigate with. You define this by saying fun intent.method, and this just adds a flag with a new task if the context is not an activity. And now you can just say intent.navigate with that, and it will just launch a new activity for you. You can do anything you want with this. Like I said, builder-like, you can just call apply on an object, and inside this context here, this lambda, you have an implicit reference to the object. So I can call setters on this. So you can use existing objects that don't have a builder in a builder-like fashion. And I'm very close to being done. You can also decorate things. I'm going to very quickly go over this. Let's say you have a method class with a few methods, many, many more here. And a method here is expensive. It might do a network call or whatever. So you want to basically bunch calls to this method into buckets. So let's say everything that happens within 200 milliseconds, I only want one call of them. So you can create a decoration by delegating all the calls and having a debouncer here. The details are not important how this is done. The idea is that you override this method and you do something different. But you still have to override all these other methods and delegate their calls, which is annoying, especially if you have like 20 methods. You can do the same thing by literally saying this class is implementing this interface by delegate, by this object. So it forwards all the messages, all the method calls to this object, apart from the ones you overrode. So this is very useful. And many, many much more. Like I said, go check the cons. And now I don't think I have time for questions, do I? I will be available for questions if you need. All right, thank you.